Okay, so if I have an exponent, what kind of exponent do I need to put on something to make something negative? Like a negative number from a positive number. All right, so somebody said a negative exponent, right? So if I have 2 to the negative 3, right? That is 1 over 2 cubed, which is 1/8. So that doesn't make it negative. All right. So if somebody said a fraction. If I have 25 to the 1/2, that really means the square root of 25, which is 5. If you have a negative base, it's technically a negative sign in front of a number, which it does make it a number, but it's not valid. The answer to the question, what exponent do I need to put on something to make it negative, is there is no such animal. So if you have negative numbers in these equations coming up that I just handed you, it's going to resolve itself so that you don't have negative. But the examples on this page will require logarithms. So get out your formula sheet for logarithms. So the first thing we do is we leave the guy with the exponent alone. So we have to subtract 8. So 25.1 minus 8 is 17.1. Okay? And unless you guys have the logarithmic tables in your head memorized, which I'm not aware that I didn't see that in anybody's file, you've got to put this in logarithmic form, okay? So what you do is you put log, and the base goes here in a small print, and the base is the guy that's holding up the exponent, so it's the 12. And then you put the answer of the answer, which is 17.1, equals the exponent. Right there. The answer to a log problem is the exponent that you have to put on that base to get that answer. The base is always like the Statue of Liberty holding up the exponent, okay? The base. And then the answer is the guy that's all by himself on the other side. All right, so in your calculators, put this in. Some of you have a log button when you hit the alpha something, y equal or something, and then some of you don't. If you don't, you type in log of 17.1 divided by log of 12, and I think that's one of you. So what I get on my calculator is 1.1425292223, and that's going to equal 7m. So we don't have m yet until we divide that by 7. Second answer divided by 7. And you always round these to 4 places. So that should be your answer for number, what was this, number 10? So the first thing we do here is subtract 5. So we have 15 to the k minus 4 equals 72. And now we're ready to put this in exponential form, in logarithmic form, because we've got the guy with the exponent alone. So it's log base 15 of 72 equals k minus 4. Then we put this in our calculator, however we have to do it to find that ugly decimal. So when I find the log base 15 of 72, I get 1.579241817 equals k minus 4. So I have to add 4 to that, and I get 5.5792 when I go to 4 decimal places. Now on this one, the biggest mistake made is that you take -3 plus 17 or times 17 and multiply those. But this 17 has the exponent on it, not the -3. So you've got to get rid of the -3 by dividing both sides by -3. And they go away. So now you have the 17b plus 8 equals, and that's going to be 23, I believe. So now all your negatives resolve themselves and all that. You've got the number to the exponent equals the answer. So we just change that to logarithms. And we do log base 17 of 23 equals b plus 8. So we get 1.106691885 equals b plus 8. So we've got to subtract 8 from that. And we get negative 6.8933 is your answer to 4 places.